Alright, this is the blank notebook for project number 7, and this project covers advanced data analysis and data aggregation techniques. So we are working with the US baby names dataset on a national level. And first of all, you have to load and inspect the dataset stored in the CSV file usbabynames.csv. And you should save the data frame in df. And then first of all, you should find the most popular baby names in 2018. So girl names and boy names. And then it's best to create a user-defined function with the parameters year, gender, and n that can return the n most popular male or female names in a specific year. And with this function, you can find the evergreen female and male names. So in my definition, evergreen names are those names that are among the top 20 in the year 1880 and also in 2018, so in these 2 years. And here you should find the evergreen boy names and the evergreen girl names. Then next in assignment 7, you have to create the following aggregated data frame egg. And here's a screenshot covering the first 5 rows and the last 5 rows. And here on the left-hand side, we have a multi-index with all combinations of name and gender. And for example, here in the very first row, we have the combination Aben and M. So this is Aben as male name. And in the total data set, we can find 114 boys with the name Aben. And we can find that combination here in 11 years. And the first year is 2007 and the last year 2018. And actually the best year with the highest count is the year 2014. And there we can find in total 16 boys with the name Aben. So this is the aggregated data frame egg. And it's definitely a bit tricky to get this data frame here. And finally, you should reset the multi-index here and create a range index. And finally, you should filter egg for the combination Mary female. And then starting with the egg data frame, you have to find the 10 most popular male and female names of all times in terms of total count. So this is here the screenshot with the final result. And first of all, we have here the top 10 female names, starting with Mary and the total count. Then we have Elizabeth and Patricia and so on. And then we have the most popular male names. And the most popular name is James, then John, Robert, and so on. Then next we should discover some general trends over time. And first of all, you have to count the total number of registered babies per year and visualize. So in 1880, we have registered only, I think it's 500,000 babies. And this is increasing over time. And then you should also count the total number of unique names per year and visualize. And to be more precise, the total number of unique combinations between name and gender. So for example, the combination Mary female, so the female name Mary is one unique combination, and the combination male and Mary is another unique name. And as we can see here, the diversity increases over time. Now, to check whether a name is popular or not, we have to create 2 additional features, popularity and rank. And we have to add those 2 columns to the data frame df. And actually, popularity should be in babies per million. And as an example, let's assume that we have 2 million registered girl names in the year 1950. And thereof, we have 100,000 Marys. Then we can calculate the popularity score for 1950 for female Mary, and it's actually 100,000 divided by 2 million times 1 million. And then we get the score, which is 50,000 per 1 million. And then you should also add rank to df. And as an example, let's assume that Mary is the most popular girl name in the year 1950. Then we should assign the value 1 for the row with Mary female in 1950. So let's have a look at the final result and how df should look like after adding popularity and rank. So here we have the first 5 and the last 5 rows for df. And we have the additional columns popularity and rank. And as you can see here, among the female names in 1880, rank 1 is Mary, and then we have Anna at rank 2 and so on. And then the next step, we can also visualize the popularity and the rank over time for specific names, for example, Mary. And obviously we can observe a declining popularity of the name Mary. So the number of Marys per 1 million baby girls is declining. And obviously Mary was at rank 1 for a very long time. But today Mary is only at rank 120 or 150. And for example, you could create this plot here for all evergreen names that we discovered in the questions 5 and 6. Next, we want to find some names where the popularity suddenly changes. And therefore, in a very first step, we have to add the additional column pop lag 1 with the popularity 1 year ago. And with that column, we can calculate and add the additional column pop diff. That is the change in popularity from the previous year to this year. And we add both columns to df. Then we should slice df and only select the year starting with 1900 until today. And save the slice data frame in df2. And then we should filter df2 and find the 20 largest values in the column pop difference. And so we have 20 combinations of names and gender. And then we should also create the popularity or rank plot for those names filtered in question 19. And for example, the names Linda, Shirley, and Jason are 3 names where the popularity suddenly changed. And if you like, you can search the web and find out why the popularity suddenly changed or spiked in some years. And finally, let's analyze the most popular unisex names. So unisex names are those names that are given to boys and girls. So this is the tricky project 7, but nevertheless, I hope you have some fun and seeing you also in the solutions videos. Bye. In this first coding lecture, we are going to find the most popular baby names in 2018. That's the most recent year where data is available. And first of all, we import some libraries for this and also for the next lectures. So we import pandas, matplotlib, and numpy. And we set the number of displayed decimals in floats to 2. And then we import the CSV file US baby names and save the data frame in the variable df. So this is df here. And we can also have a short look at some meta information. So we have almost 2 million rows. We have 4 columns. And we have 2 columns with text or string data, name and gender. And in total, we have a memory usage of almost 60 megabyte. And now in the next step, let's check the number of unique values in the columns with n unique. And here we can clearly see that the gender column is clearly a categorical column with only 2 different or unique values, F and M, so female and male. And it could make sense to convert the data type of the gender column to category. And now let's inspect how the memory usage changes. So from almost 60 megabyte to 46 megabyte. So our data frame df contains data from 1880 till 2018. And in this lecture, we are interested in the most popular names in the most recent year, 2018. And therefore, first of all, we slice the F and we select only those rows where we have the value 2018 in the year column. And we create a copy and we save it in the variable names 2018. And here we have 32,000 rows now. And first of all, we are interested in the most popular female names. And therefore, we filter our names 2018 data frame by the gender and we select female. And actually, we are interested in the 10 most popular names. So we chain here n largest and we are interested in the 10 most popular female names. So we have here the count column. And let's have a look here. So the most popular name is Emma, then we have Olivia, Ava, Isabella, and so on. And the count is, for instance, for Emma is 18,688. Next, let's create a simple and straightforward function, most popular. And here we can define the year, the gender, and the n most popular names. So most pop should actually return a data frame where we filter the year column for the year that actually we can pass here, and also for the gender. And finally, we select the n largest. So now let's define the function. And it's called the function for the 10 most popular female names in 2018. So this is nothing new. And the same we can do for the 10 most popular male names. So instead of passing f, we pass m here to the gender parameter. And here we get the most popular male names, Liam, Noah, William, James, and so on. Alright, thanks for watching and see you also in the next lecture. Bye. The popularity of names can change over time, and the question is, are there any names that were popular 140 years ago and that are still popular today? And I call those names evergreen names. And before we can start, we have to define popular, and in my definition, a name must be at least in the top 20. And first of all, let's get the evergreen female names. And we get the 20 most popular names in 2018 and save those in the data frame F 2018. And then we do the very same for the year 1880, so the 20 most popular female names. And now the plan is to get those names that are in both data frames in the 2018 and in the 1880 data frame. And we can actually do this with a inner merge. So we can use the merge method. And we apply the merge method on the data frame F 2018. And we're only interested in the name column and the count column. And then we pass the right data frame, so the 1880 data frame, and we have to perform an inner join, and therefore we pass inner to the how parameter, and the join should be on the name column. So pandas should return all names or all rows that are in both data frames. And let's have a look here. And we have in total 3 names, Emma, Elizabeth, and Ella. And for both years, we have the count. And by default, we have the suffixes x and y. But it could make more sense to have more meaningful suffixes like the year. So for the left-hand data frame, it's 2018. And for the right, 1880. So we pass a tuple with the suffixes to the parameter suffixes. And then we save the merge data frame in female evergreen. So let's have a look. So now it's clear that the first count column is for 218 and the second count column for 1880. And the same we can also do for males. So we get the most popular in 1880 and 2018. And again, we perform the inner join. And we save the resulting data frame in male evergreen. And let's have a look here. So in total, we have 3 evergreen male names, William, James, and Henry. All right, thanks for watching, and see you also in the next lecture. Bye. In this lecture, we are going to aggregate the baby names dataset and, for instance, get for all names the total count from 1880 till today. And first of all, we import the baby names dataset and save it in the variable df. So this is nothing new. And then we have to group df by name and gender, as some names are so-called unisex names. So we should consider all combinations of name and gender, and you will see later that we get one group with the female name Mary and one group with the male name Mary. And as an example, let's get the total count since 1880. So we have a look at the count column and take the sum. And here we get a panda series with a multi-index on the left side with all combinations of name and gender, where we have some data. So for instance, we have the combination A-ban and male. So this is obviously not the most popular name, with in total 114 counts. And in total, we have over 109,000 combinations of male and gender. And now we can also remove the multi-index and convert the inner index level gender into an ordinary column. And we can actually do this with a reset index. And we define that we want to reset the column at index position -1. So the most right-hand index gender. So let's do this. And now we have here a pandas data frame with 2 columns, gender and count. So that's one example. And now let's create many aggregations. And again, we group by name and gender and use the agg method. And first of all, we want to create the aggregation total. And this simply sums up the count to get the total count. Then we get the number of years where we can find the combinations in our data set. So we actually count the number of occurrences, for instance, in the count column. Then we get the very first year by taking the minimum in the year column, and also the last year by taking the maximum in the year column, and finally also the maximum count in a particular year. So let's create the new data frame agg. And let's have a look at agg. So for instance, for the combination A-ban and male, we have in total 114 counts. And we have 11 years from 2007 till 2018. And actually in the best year, we have a count of 16. And now in the next step, we can also get the best year. And this is a bit more complicated. So actually we can do this with the apply method and create a function that returns the best year. So let's have a look at the function best year. And for each and every group, or to say for each and every combination of name and gender, we get the row with the largest number in the count column. And we are interested actually in the year, so in the best year. So let's define the function here. And let's apply the function to our group by object. And we save the result in best year. So this is a pretty complex operation, and it could take some time. Now let's have a look at best year. And for instance, for the male A-ban, the best year is 2014. And actually now here we have a panda series with a multi-index and 3 index levels. So here we have actually one row label of the particular combination in the original data frame df. And we can simply drop this level here. So this level is at index position -1. And then we are left with name and gender in the index. And then we can also add this best year to agg. So now let's create the additional column best year here on the right hand side. So the best year for A-ban is 2014 with a maximum count of 16. And finally we can also reset the index and create a range index and convert name and gender into a column. And we save the change. And that's actually our final data frame agg. And now we can also filter for a combination, for instance, Mary and female. And here we get a total count of over 4 million. And we can find Mary as a female in all years, in all 139 years from 1880 till 2018. And the best year with a count of almost 74,000 was 1921. And actually, even if Mary is a way more popular female name, there are also some males with the name Mary. So let's filter for Mary and male. And surprisingly, still we get a total count of over 15,000. So even if Mary is way more popular for females, it's actually a so-called unisex name. Alright, thanks for watching, and see you also in the next lecture. Bye. Now in this lecture we use the aggregated data frame AG to determine the most popular names of all times. And actually the plan is to get the 10 most popular male names and the 10 most popular female names by the total count. And therefore we split AG by the gender into males and females. And we apply the following lambda function. So for the male data frame and the female data frame, we actually get the 10 largest rows by the total column. And here on the left hand side we have now a multi-index, and first of all we have the 10 most popular female names, and then the 10 most popular male names. And actually we can also see that we have the gender here in the outer index level and also as column, and in the inner index level we have some row labels that are not really meaningful, and therefore we can simply re-index our data frame and remove the multi-index and create a range index. And that's exactly what we are doing here. And we save the new data frame in the variable all times. And here we have the 10 most popular female names, starting with Mary, Elizabeth, Patricia, and so on. And then here in the tail we have the 10 most popular male names with James, John, Robert, and so on. Now in the next step we can also visualize this with a seaborn bar plot. And first of all we import seaborn as SNS. And here we get a future warning message. So for both the pandas and seaborn I have the latest versions installed. But as this is just a future warning, we don't have to care about that at the moment. So let's simply create the seaborn bar plot. And here we can see in blue the most popular female names with Mary, Elizabeth, and so on. And obviously Mary is by far the most popular female name. And for the male names it looks a little bit more balanced. So here we have James, John, Robert, and so on. Alright, thanks for watching, and see you also in the next lecture. Bye. So far we have worked with the count, which is an absolute number. For instance, we had 7,000 female Marys in 1880. And now the question is this a good indicator for a name's popularity? Probably not, since it does not take into account the total number of registered female names in 1880. And I would suspect that the number of registered babies has increased over time. So to measure popularity, it might make more sense to work with the relative count, for instance, per 1 million babies. And therefore, first of all, we should try to discover some general trends over time in this lecture to figure out the most appropriate metrics for the popularity of names. And first of all, we set the number of displayed decimals and floats to 0. And then we count the total number of registered babies per year, and we save the result in the variable babies per year. So we split the data frame df by the year into 139 groups, and then we actually sum up the numbers in the count column. And here we can see that in 1880 we had around about 200,000 baby name registrations. And actually 138 years later we had almost 3.5 million registered names, baby names. So there's a factor of more than 15. And I suspect there are two major reasons for the increase. So the population and the number of births steadily increased in the last 140 years. And second, the percentage of registered babies increased. So I guess in 1880, way more babies were not registered at all. So we should keep in mind that the counts in our dataset is not equal to the number of births. So it rather reflects the number of registered babies or names, and only those names with a count of at least 5 in a particular year. And we can also visualize this trend over time by plotting babies per year with a bar plot. So we pass bar to the kind parameter, and on the y-axis we want to have the total count per year, and we define the figure size and the font size, and we define the ticks here. So let's simply have a look. And here on the x-axis we have actually the years, so we can see the ticks with the 5-year increments, and on the y-axis we have the total count. And indeed we can see here a continuous increase of registered babies or names in the last 140 years. Next, let's figure out whether the number of unique names increased over time, so to say whether the names are getting more diverse. So let's group DF by the year, and let's count the number of names. So we create the Panda series, different names. And in 1880 we had 2,000 different names. And we can see that there's a steep increase. So in 2018 we had over 32,000 different names. And it's important to mention that these are not the number of unique names. So we have female Marys and male Marys, and both are included here in the 2000. So these 2000 here are actually unique combinations of name and gender, so that's important here. And finally, also here we can plot the trend over time. So we use the plot method on different names, and we create a bar plot. So here we can see a steady increase of the names. So the names are getting more diverse over time. And therefore we could conclude that the relative count is more meaningful than the absolute count, and also that the relative counts should decrease over time as the names are getting more diverse. So the relative rank of names should give us even more, or at least a different information on the popularity than the relative counts alone. And that's exactly what we will do in the next lecture. So we will create 2 additional features: the popularity in terms of babies per 1 million, and also the relative rank. So hope to see you there. Bye. In this lecture, we are going to create 2 additional features for our baby names dataset: popularity in terms of babies per million, that's the relative count or relative frequency, and second, we rank baby names per year and gender. For instance, the name Mary had the first rank among all female baby names in 1880. And these 2 features are better metrics for a name's popularity than just the total count. So we have still imported df. And now we want to create the 2 additional features, popularity and rank. And first of all, let's focus on the popularity, so babies per 1 million. And actually to calculate the relative frequency, for instance, for Mary, we have to figure out the total count of female names in 1880. So we should calculate 7,065 divided by the total names or total count. And therefore, first of all, we have to group by df, by year and gender. And then for each combination of year and gender, we sum up the counts in the count column. So for instance, in 1880, we had 90,000 registered female names and 110,000 registered male names. So to calculate the popularity or the relative frequency of Mary, we have to divide 7,065 by 90,994. And then to get the relative frequency in terms of babies per million, we have to multiply with 1 million. And then we get the relative frequency or the popularity of 77,642. And actually there's a pretty powerful way to calculate the popularity for all names. And first of all, we can assign the total count to all names that belong to the respective group. So we can assign 90,994 to all names in the group 1880 and female. And we can do this with the transform method. And then we can define that we want to have the sum. So let's again run the cell. And now here we have for all female names in 1880 the total count of 90,994. And then for each and every name we can divide the individual count by the total count. And that's exactly what we are doing here. So we take the values in the count column and divide by the group-specific total count and finally multiply with 1 million. And for instance, here in the first row, this is Mary, and we get the relative frequency or popularity of 77,000. So that's the same as we calculated here manually. And finally, we can create the additional column popularity and actually take those values here. So let's have a look. So for Mary, we have 77,000, for Anna 28,000, and so on. And now finally, we can also determine the relative rank. So in the group 1880 and the female, Mary had the first rank, Anna the second rank, and so on. And to get the relative ranks, first of all, we group again DF by the year and gender. And then we consider the count column and we apply the following lambda function. So we determine the name's rank based on the count. And we pass false to the ascending parameter. And by doing so, we actually assign the rank 1 to the name with the highest count. And otherwise, if you were to pass true to the ascending parameter, we would get the rank 1 for the least frequent names. So that's actually not our intention. So here we get the first rank for Mary, the second rank for Anna, and so on. And again, we can create an additional column rank with those values here. And let's have a final look. So now we have 2 additional columns and 2 additional features in our baby names data set, the popularity and the rank. And we can also make a double check and we can filter DF for all male names in 2018. And let's get the 60 most popular names. And here we have Liam with a total count of 19,000. The popularity in terms of count per 1 million, so it's 11,000, and the rank 1. And we can also get the 60 least frequent names with the tail method. So here we have all names with a count of 5, a relative count of 3, and the rank 13,000. And finally, to make a more detailed cross-check, we could sum up the popularity, and the sum should be 1 million. So because we have here the popularity in babies per million. And let's do this here. So we sum up all elements in the popularity column for male names in 2018. And indeed, we get here 1 million. All right, thanks for watching and see you also in the next lecture. Bye. In this lecture, we are going to visualize name trends over time, and we have still the data frame df. Then we can filter df for a name, for example, the female name Mary. And here we can see the count, the popularity, and the rank over time between 1880 and 1939. So in each and every year, Mary was the most popular female name. And let's have a look at the most recent years with the tail method. And here we can see that from 1960, the popularity of Mary declined. So now most recently, Mary is at rank 126. So we have learned before that combined together, the metrics relative count in babies per million and the rank pretty well measure the popularity of names. And in order to detect and analyze changes in popularity over time, it's best to visualize the popularity and rank over time in one figure. So let me just create an appropriate plot and let me explain the code immediately afterwards. So this is the plot for Mary. And in blue we can see the popularity, and it obviously declined over time from almost 80,000 per 1 million to less than 10,000. And it's no surprise that the rank simultaneously increased over time from rank 1 to 124. And actually it's a bit more complex to create this plot here because we have a single plot containing two features with different scales, and therefore we need two y-axes. So the first one on the left-hand side for the popularity in babies per million, and this is here in the thousands. And on the right-hand side, the secondary y-axis rank, which is in this case here between 0 and 120. And also we have two different plot types. For popularity, we have a bar chart, and for the rank, we have a line plot. So this is getting more complex, and we have to select a more general way of plotting, the object-oriented style, where we have to explicitly create figure and axis objects. So let's have a look at the code. And first of all, we create the figure and the axis one object with pld.subplots, and we can define the figure size. So axis one is the object to create the popularity bar plot, and we can do this with the bar method. And we can define that on the x-axis we want to have the year, and on the y-axis the popularity. So we have to pass here Mary.popularity to height. Next we can create a twin object x2 for the secondary y-axis with twinks, and x2 is actually the object for the rank line plot. So here we create the line plot, and we pass to x the year column, and to y the rank column. And also here we can define, for instance, the color and also the label. And then the next step, we can set x and y labels. So for the x label, we have year. And for the first y-axis, babies per million. And for the secondary y-axis, rank. And we also set a title, Mary. And then with the tick params, we can customize the label size here of the numbers to, for instance, a label size of 12. And finally, we add the legends to both axes. So we have popularity and rank here. And then we can use plt.show to actually create the graph or display the graph here. So that's how we can create the plot. And now let's create a user-defined function plot name, where we can pass the name, the gender, and the criteria for the bar plot. So by default, it's popularity, but we can also change this to count. And what the plot name actually does, it first of all filters df for the name and for the gender. Then it only selects the columns name, gender, year, and rank, and also the criteria. So here either popularity or count. And then it sets the year column as the index. And then we are actually creating the plot with the code that we already know. So let's define the function plot name. And let's call the function for Mary female. And by default, we have here on the left-hand side the popularity and the ranks. So this is here actually nothing new. But we can also change the criteria to count. And now we have here the absolute count over time and again the rank. So even if the absolute count increases in the 1940s and 50s, the relative count is still decreasing because the total number of babies or names were increasing in that time period. All right, let's have another example, and let's take the male name James, and let's select popularity. And actually we can see that the relative frequency is declining over time, and the rank is actually increasing. But then finally, beginning in maybe 2010, the rank is decreasing again. So from rank 18 to rank 3, I guess, or 4. However, there's only a small increase in relative frequency that causes a large decrease in the rank. And that could be due to the higher diversity of names. All right, last but not least, let's focus on our so-called evergreen names. So we have male evergreen, William, James, and Henry, and let's create a for loop, and let's create the plots for all three names. So here we have William. And even if the popularity is continuously decreasing over time, here for the rank criteria, we have actually a spike in the year 2000. And then after that, in the most recent years, Williams recovered from rank 20 to rank 3, I think. And the same pattern we can also see for James. And for Henry, the trend is pretty clear. So popularity and rank lost ground until the 90s, and then it again recovered until today. So maybe it's wrong to call Henry, William, and James evergreen names, because they had some spikes here in the 90s and the 2000s, but now they are back again. And finally, let's have the same analysis also for the evergreen female names. So we have Emma, and also here we have the same pattern. We have Elizabeth, and also we have Ella with also the very same pattern. So we could conclude that there's a revival of traditional names that gained popularity in the most recent years. All right, thanks for watching, and see you also in the next lecture. Bye. In the next two lectures, we try to find an answer for the following question: why does the popularity of names suddenly change? And before we can answer the question, we have to detect names with sudden large positive or negative changes in popularity. And we need to find an appropriate feature that measures changes in popularity. And the simplest way is to calculate the difference in popularity from one year to another and find the most extreme values. So we have still saved df, and then we can filter for female Mary and only for the column popularity. So this is the popularity for 1880, then here for 1881. And with the shift method, we can actually shift the popularity by 1 year. So to say, we get for 1881 the value for 1880, 77,000. And so to say, we can create the leg 1 or the first leg. And let's do this here with shift. And it's obviously no surprise that in the very first year we get a missing value, because we do not know the count for the year 1879. So this is the first leg for Mary, but we want to have the first leg for each and every combination of name and gender. And therefore, again, we have to group df by name and gender, and then we perform a shift in the popularity column. And we save the first leg in the column pop leg 1. So let's do this. And let's inspect. So now here on the right hand side, we have the additional column pop leg 1. And it's no surprise that for the year 1880, we get missing values. And this is actually totally fine because we simply do not know the leg because we do not have any data for the year 1879. But still we have one problem now, and let's, for instance, filter for the name Ashanti. So the first year for Ashanti was 1970, and obviously Ashanti is a unisex name, so we have males and females in the year 1970. And we have missing values in the column pop leg 1. However, we can conclude that in the year 1969, we had less than 5 Ashantis. So this is very close to 0. And therefore, we should do the following. So we should replace all missing values in the pop leg 1 column. In all cases where the year is greater than 1880, and actually where we have a missing value in the pop leg 1 column. So we filter actually and override missing values in the pop leg 1 column by 0. And let's again have a look at Ashanti. And now instead of having here a missing value in the year 1970, we have simply the pop leg 1 value 0. Now we have the popularity and also the leg 1. And with this information, we can also calculate the difference in popularity from one year to another. And we can simply do this with a subtraction. So we subtract pop leg 1 from popularity and create the new column pop difference. And again, let's have a look at female Mary. So now here on the right hand side, we have the additional column pop differences. And for the first year, we have a missing value. And then in 1881, we have minus 2,400. So that's the difference between 75,000 and the leg 1, 77,600. So the popularity decreased from 1880 to 1881, and therefore the difference is negative. And in the next year, we have a positive difference because the popularity increased again to 75,500 from 75,200. And also we can have a look at Ashanti. And here in the very first year, 1970, we have a popularity of 8 for both females and males. And we have an assumed leg 1 of 0. And therefore we have a difference of 8. Now let's go on and let's only consider all names starting in the year 1900. So we filter df and we create a copy and then we save it in the variable df2. So now we're starting in the year 1900 and still we have Mary in the first rank. Now we can sort df2 by the popularity difference, and we are interested in the 20 largest or 20 most positive differences. And here we get in the year 1947 Linda with a difference of 22,000. So actually it increased from 33,000 to 56,000. Then we have Shirley in the year 1935, then Ashley, Jennifer, and the first male name is Jason in the year 1973. Now the question is, what are the reasons for the steep increase in popularity? And actually Linda is a popular song written by Jack Lawrence, and it had topped the charts in the year 1947. Next, we have Shirley, and actually Shirley Temple was Hollywood's #1 movie star between 1935 and 38. And let's have a look at Jason finally. So Jason Miller was acting in the movie The Exorcist in the year 1973. And we can also create the plots for Linda, Shirley, and Jason. So here we have the steep increase in 1947. And here's Shirley, and finally we can also have a look at Jason. And last but not least, we can also get the highest negative changes with n smallest. And actually here we get Shirley in the years 36 and 37, and also Linda, Jennifer, and so on. Alright, thanks for watching, and see you also in the second part. Bye. Alright, in this lecture we will gain some more insight into sudden changes, and first of all let's get what I would call from 0 to 100 names that are names that more or less didn't exist before and then suddenly appeared out of nowhere. So first of all, let's filter DF for all names where we had in the previous year a popularity of less than 5. So it actually didn't exist, the name. And then we sort by popularity difference and get the 20 largest or the 20 most positive changes. And here we have Nakia, Kizzy, and so on. And actually we can also filter for Nakia, and obviously this is a female name and also a male name, but actually it was more popular as a female name. And let's also get the plots first of all for the female Nakia and for the male. And actually we can see here that Nakia suddenly appeared in the year 1974. And the reason is that Nakia was a 1974 United States dramatic TV series. And actually the leading movie character's name was Nakia. So original Nakia was a male name in that series. But obviously it was more popular as a female name. Next, we can also have a look at Kizzy. That's a female name. And also Kizzy was a US TV series in 1977. And let's also have a look at some other singers, actors, and sports stars. For instance, Rihanna. And it's no surprise that Rihanna gained popularity around about 2008, 2009. And same applies also for Whitney. So Whitney Houston was one of the most popular actors in the 80s and 90s. And finally, let's have a look at Shaquille. So we all know the basketball player Shaquille O'Neal. And also we can see here a spike in the 90s. So we can conclude that TV series, movie characters, actors, singers, and sports stars influence the popularity of names. And now in the next step, we can also analyze the highest percentage decrease among popular names. So we have still TF2, and we can create the additional column percentage change. And this is simply the popularity divided by lag1, -1 multiplied with 100. And for instance, we have Mary in the year 1900, and the percentage change from 1899 to 1900 was -1.42%. And now we can also filter DF2 for all names with a popularity of least 1000 and get the 20 names with the highest negative percentage change. So here we have in the year 1974 Katina, and Katina dropped by almost 70%. Then we have Aisha, Ashanti, and so on. And the first male name is here Woodrow in the year 1920 with a decrease of 60%. So let's also have a look at the female name Katina. And we have here a clear spike in the year, I think it's 1974. And then 2 years later, it massively dropped again. And actually, Katina was a singer. And let's have a look at Aisha, a female name. And here we had a spike in the year 1991. And then it dropped again dramatically. And Aisha is actually a song. Next, we have the female name Ashanti, and here we can see a spike in the year 2002, and then a sudden drop. And it's no surprise that Ashanti was a singer and songwriter, very successful in the year 2001 and 2002. And finally, we have the male name Woodrow. And actually, Woodrow lost some ground in 1919 and 20. And the reason might be that Woodrow Wilson was the US president at that time. And finally, we can also analyze Hillary. And also Hillary dramatically dropped in the 90s. So this might be caused by the fact that Hillary Clinton was the first lady. So we can also conclude that politics and politicians actually influenced the popularity of names. And it seems like that it negatively influenced that. So these were the sudden changes, and in the next video we will have a closer look at persistent versus the spike fade names. So thanks for watching and see you there. Bye. This is an exploration of names with different dynamics, those that stay consistently popular through centuries and those that have sudden spikes in the total count and then fade away quickly. And the criteria in this lecture is the absolute count and not the relative count per 1 million, but we could also use the ladder. So we have still saved the aggregated data frame AG with, for instance, the max count in a particular year and the total count. And next we create an appropriate spike score that should be a good measure of the dynamics. So we create the new column spike score, and then we divide the max count by the total count and multiply with 100. So now let's do this. And let's have a look. So now here on the right hand side we have a spike score, and the spike score is between 0 and 100. And the lower the spike score, the more persistent the name. And the higher the spike score, the more flash-like the name is. So now let's go on and let's sort AG by the spike score from low to high, so in an ascending order. And let's get the 20 most continuous or persistent names. And here we have Joseph with a spike score of 1.25, and then Elizabeth with 1.27, and so on. And actually we can save the 20 most persistent names in the variable pers. And now we can create a list with name gender pairs, and we save the list in the variable L. So here we have the list L containing 20 tuples, and in each and every tuple we have the combination of name and gender. Now we can also plot the popularity profile with the plot name function, and we iterate over the list L, and for each and every tuple or combination of name and gender we actually pass the name to the name parameter and the gender to the gender parameter, and we actually select the total count as criteria. So let's run the for loop here. And here we have the most consistent name, Joseph. Then we have Elizabeth, Rosa, and many more. Next, let's focus on the spike fade names, and first of all we should filter AG and get only those names where we have more than 1000 in the total count and more than 10 years, and then we sort by the spike score and get the 20 names with the highest spike score, and we save the resulting data frame in spike. So for instance, here we have Izzy, Oakland, Danine, and so on. And again, we can zip name and gender together and create a list with 20 tuples. And again, we can iterate over list2 and create a plot for all names. And again, the criteria is here count, and we have here Kizzy, Oakland, and many more. And actually the spike of all of these names are probably caused by actors, singers, sports stars, and so on. Shaquille, Katina, Nakia, and many more. Alright, thanks for watching, and see you also in the next lecture. Bye. In this lecture, we try to find the most popular unisex or genderless baby names of all times. So these names are given to boys and girls, and actually unisex names are common in the English-speaking world, especially in the United States. So I think we will be successful and find some great unisex names. And we have still imported and saved the data frame df. And the question is now, how can we measure the popularity of unisex names? And two criteria must be met. So first of all, the name must be popular in terms of total count. And second, the name should be more or less equally spread among boys and girls. So it must be a popular boy's name and also a popular girl's name. And now let's check this out for the name Mary. So we filter df only for Mary. And we group by name and gender and take the total count. And here we get the total count for the female and the male variant Mary. And even though Mary is actually one of the most popular names of all times, and it's also given to boys, I wouldn't call it a unisex name because Mary is not at all equally spread. So it's actually a female name with some exceptions. So we have over 4 million females with Mary and only 50,000 male Marys. Now let's have a look at all names, and again we group by name and gender and take the total count. So this is nothing new. And for instance, we can see that Aben is clearly a male name with a count of 114, and we have 0 counts for the female variant. And now the next step, let's unstack here the panda series. And we can do this with unstack, and we create 2 columns, male and female. So let's have a look here. And by doing so, we create missing values for all combinations of name and gender where we have 0 count. So for instance, for the combination Aben and female, we have here a missing value. So now let's save the data frame here in the variable unisex. And let's drop all names or all rows where we have a missing value. So these are clearly not unisex names like Aben. And of course we can do this with drop in A. Now in the unisex data frame we have all names that were given to female and male. And also Mary is here included, but again I wouldn't call Mary a unisex name. And the question is now how to define and measure the popularity of unisex names. And in the next couple of minutes, we apply 2 different measures. So first of all, we get all those names with the highest total count in the less popular variant. So for each name, we get the minimum count among the boys and the girls variant. So we use here the min method, and we actually apply it for each row or along the columns. So let's have a look here. And for instance, for Aiden, we get the less frequent variant. It's the female variant, 5. And now let's sort all minimum values from high to low. So we pass false to the ascending parameter. And according to our first definition, here we have the most popular unisex names, Willie, Jordan, Leslie, Taylor, and Jesse. So for instance, for Willie, we have a count of 146,000 for the less popular variant. And next, let's take the index here, so the names, and save the names in the variable unisex names. Willie, Jordan, Leslie, and so on. And now let's get the row of the 20 most popular unisex names in the unisex data frame. And again, here we have Willy, and the less popular variant is the female variant with 146,000. And in the male variant, we have almost 500,000 counts. And now let's come to the second method. And in the second method, we try to find those names that are as equally spread as possible, so 50-50. However, first of all, we should define that the less popular variant should have a count of at least 10,000. So we actually filter for all unisex names where we have in the less frequent variant at least a count of 10,000, and we actually override the unisex. And now we want to find those names that are equally spread, so 50-50. And mathematically, we can do the following. So we can divide the female count by the male count. And if we have 50-50, this should be very close to 1. And then we subtract 1. So this should be very close to 0. And then we take the absolute value. So we can be sure that we only have positive numbers. And then we sort the values from low to high. And the names with the lowest values are actually more or less equally spread among boys and girls. So let's have a look here. And here we have Alicia, Quinn, Carrie, Blair, Chris. So let's take the names here and let's save the names in the variable unisex names too. And again, let's have a look at the rows in the unisex data frame. And here in the first position, we have Alicia with 13,700 females and 13,600 males. Then we have Quinn, Carrie, Blair, Chris, and so on. All right, thanks for watching, and see you in the next lecture. Bye.